The National Electrical Code does not explicitly prohibit connecting rigid conduit to a dry-type transformer. However, there are some potential concerns to consider. Firstly, vibration. Dry-type transformers can produce vibrations, especially under load. Rigid conduit is more susceptible to transmitting vibrations compared to flexible conduit. Excessive vibration can cause damage to the transformer or other connected equipment. Secondly, expansion and contraction. Dry-type transformers and rigid conduit expand and contract at different rates due to temperature changes. This can lead to stress on the connection and potential loosening over time. Thirdly, grounding. Proper grounding is critical for the safety and performance of the electrical system. When using rigid conduit, it's important to ensure there is a continuous electrical path from the transformer frame to the grounding electrode system. Based on these considerations, it's generally recommended to use flexible conduit or cable tray to connect to dry-type transformers. Flexible conduit provides more flexibility to accommodate vibration and expansion/contraction. Cable tray allows for easy access for inspection and maintenance. While the NEC may not specifically address this issue, other codes and standards may provide guidance. For example, the National Fire Protection Association 70E standard for electrical safety in the workplace recommends using flexible connections to transformers to minimize vibration transmission. Based on the information provided, it's not advisable to pipe directly into and out of the transformer with ENT due to potential vibration concerns. Instead, it would be recommended to use flexible conduit or cable tray to connect the ENT to the transformer. The National Electrical Code is a comprehensive set of standards that governs electrical installations in the United States. It is updated every 3 years and provides guidelines for safe and effective electrical practices. When dealing with transformers, it is important to understand the specific requirements outlined in the NEC. The NEC addresses various aspects of transformer installations, including overcurrent protection, grounding, and wiring methods. Understanding these requirements is crucial for ensuring the safe and reliable operation of electrical systems. Dry-type transformers are commonly used in commercial and industrial applications. They are designed to operate without the use of oil or other liquid coolants. Dry-type transformers are generally smaller and lighter than liquid-filled transformers, making them suitable for indoor installations. However, dry-type transformers can be more susceptible to overheating and vibration. Therefore, proper installation and maintenance practices are essential. Vibration in transformers can be caused by several factors, including the magnetic forces within the core and the mechanical stresses from the windings. These vibrations can be transmitted through the transformer enclosure and into the connected conduit. Rigid conduit, which is typically made of steel or aluminum, is an excellent conductor of vibration. Therefore, it is important to consider the potential for vibration when connecting rigid conduit to a dry-type transformer. Flexible conduit, on the other hand, is designed to absorb vibration. It is typically made of a flexible metal or plastic material that can dampen the transmission of vibrations. By using flexible conduit to connect to a dry-type transformer, you can minimize the risk of damage to the transformer or other connected equipment. Expansion and contraction are also important considerations when connecting conduit to a dry-type transformer. Transformers generate heat during operation, which can cause the transformer enclosure and the connected conduit to expand. Similarly, when the transformer is shut down, it will cool down and contract. If the conduit is rigidly connected to the transformer, these expansion and contraction cycles can create stress on the connection, potentially leading to loosening or damage over time. Flexible conduit can accommodate these expansion and contraction movements, reducing the stress on the connection. Cable tray is another option for connecting to dry-type transformers. Cable tray is a metal framework that is used to support and route electrical cables. It provides a convenient and organized way to run cables, and it also allows for easy access for inspection and maintenance. When using cable tray to connect to a dry-type transformer, it is important to ensure that the cables are properly supported and secured. You should also use flexible connections between the cable tray and the transformer to minimize vibration transmission. Grounding is a critical aspect of electrical safety. It provides a path for fault current to flow back to the source, which helps to protect people and equipment from electrical shock. When using rigid conduit, it is important to ensure that there is a continuous electrical path from the transformer frame to the grounding electrode system. This can be achieved by using grounding bushings and bonding jumpers. Grounding bushings are installed on the ends of the conduit and provide a connection point for the grounding conductor. Bonding jumpers are used to connect the grounding bushings to the transformer frame and the grounding electrode system. The National Fire Protection Association 70E Standard for Electrical Safety in the Workplace provides guidance on electrical safety practices for employees who work with or near electrical equipment. It recommends using flexible connections to transformers to minimize vibration transmission. This recommendation is based on the understanding that vibration can cause damage to electrical equipment and increase the risk of electrical shock. By following the recommendations of NFPA 70E, you can help to ensure a safe working environment for your employees. In summary, while the NEC does not explicitly prohibit connecting rigid conduit to a dry-type transformer, there are several potential concerns to consider. Vibration, expansion and contraction, and grounding are all important factors that should be taken into account. In most cases, it is recommended to use flexible conduit or cable tray to connect to dry-type transformers. This will help to minimize vibration transmission, accommodate expansion and contraction movements, and ensure proper grounding. Always consult the NEC and other relevant codes and standards to ensure that your electrical installations are safe and compliant. Furthermore, it is essential to be aware of the specific installation guidelines provided by the transformer manufacturer. These guidelines will often include recommendations for connecting conduit, grounding, and other important aspects of the installation. Adhering to the manufacturer's recommendations can help to ensure the proper operation and longevity of the transformer. In addition to the points already discussed, another consideration when connecting conduit to a dry-type transformer is the potential for electromagnetic interference, or EMI. Transformers can generate electromagnetic fields that can interfere with the operation of nearby electronic equipment. Rigid conduit can act as a shield against EMI, but it is important to ensure that the conduit is properly grounded. This will help to prevent the EMI from radiating into the surrounding environment. Flexible conduit, on the other hand, may not provide as much shielding against EMI. Therefore, it may be necessary to take additional measures to mitigate EMI, such as using shielded cables or installing filters. The selection of the appropriate wiring method for connecting to a dry-type transformer depends on several factors, including the specific application, the environmental conditions, and the local electrical codes. It is important to carefully consider all of these factors before making a decision. In some cases, it may be necessary to consult with a qualified electrical engineer to determine the best wiring method for your particular situation. They can assess the specific requirements of your application and recommend a solution that is both safe and effective. When working with electrical equipment, it is always important to follow safe work practices. This includes wearing appropriate personal protective equipment such as gloves and safety glasses, and energizing the equipment before working on it. Never work on energized electrical equipment unless you are qualified to do so and have taken all necessary safety precautions. Electrical work can be dangerous, and it is important to take it seriously. By following safe work practices, you can help to prevent accidents and injuries. Remember that electrical codes and standards are constantly evolving. It is important to stay up to date on the latest changes to ensure that your electrical installations are safe and compliant. You can do this by attending training courses, reading industry publications, and consulting with qualified electrical professionals. Staying informed about the latest developments in the electrical industry will help you to make informed decisions and ensure the safety of your electrical systems. The NEC, for instance, provides detailed tables and calculations for determining the appropriate size of conductors and overcurrent protection devices for transformers. These calculations take into account the transformer's voltage, current, and kVA rating, as well as the ambient temperature and the type of load being served. It is important to follow these calculations carefully to ensure that the transformer is properly protected against overloads and short circuits. Failure to do so can result in damage to the transformer or even a fire. Furthermore, the NEC specifies the requirements for grounding transformer enclosures and associated equipment. Proper grounding is essential for preventing electrical shock hazards and ensuring the reliable operation of the electrical system. The NEC also addresses the use of various types of wiring methods for connecting to transformers, including conduit, cable, and wire. Each wiring method has its own advantages and disadvantages, and the selection of the appropriate wiring method depends on the specific application and the environmental conditions. For example, in areas where there is a risk of physical damage to the wiring, conduit may be the preferred wiring method. In areas where flexibility is required, cable may be a better choice. Ultimately, the goal is to select a wiring method that is both safe and effective. In addition to the NEC, there may be other local codes and regulations that apply to transformer installations. It is important to check with your local authorities to ensure that your installation complies with all applicable requirements. Failure to comply with local codes can result in fines or other penalties. In conclusion, connecting conduit to dry-type transformers requires careful consideration of several factors, including vibration, expansion and contraction, grounding, and ME. While the NEC does not explicitly prohibit the use of rigid conduit, it is generally recommended to use flexible conduit or cable tray in most applications. Always consult the NEC and other relevant codes and standards to ensure that your electrical installations are safe and compliant. And do not hesitate to seek the advice of a qualified electrical professional if you have any questions or concerns. Remember, electrical safety is everyone's responsibility. By following safe work practices and adhering to the applicable codes and standards, you can help to prevent accidents and injuries and ensure the safer and reliable operation of electrical systems. It's worth reiterating that the absence of an explicit prohibition in the NEC does not equate to a recommendation for a particular practice. The NEC sets minimum safety standards, and often, exceeding those standards through best practices is prudent. The recommendation for flexible connections to transformers stems from practical experience and engineering judgment, acknowledging the long-term benefits of mitigating vibration and thermal stress. Selecting the right type of flexible conduit is also important. Options include liquid-type flexible metal conduit, and non-metallic flexible conduit. The choice depends on the environment and the specific requirements of the installation. For example, in damp or wet locations, liquid-type flexible metal conduit is often the preferred choice. When installing flexible conduit, it is important to follow the manufacturer's instructions carefully. This includes using the correct fittings and supports, and ensuring that the conduit is properly secured. Improperly installed flexible conduit can be just as problematic as rigid conduit in terms of vibration and stress. Furthermore, consider the impact of conduit fill on the overall installation. Overfilling conduits can lead to overheating of conductors and make it difficult to pull wires. The NEC specifies the maximum allowable conduit fill for various types of conductors and conduit sizes. Adhering to these fill limits is crucial for ensuring the safe and reliable operation of the electrical system. Also ensure the proper selection and installation of bonding jumpers. Bonding jumpers provide a low impedance path for fault current to flow back to the source, which helps to protect people and equipment from electrical shock. The NEC specifies the size and installation requirements for bonding jumpers. It is important to follow these requirements carefully to ensure that the bonding jumpers are effective. Regular inspection and maintenance of transformer connections are essential for ensuring their long-term reliability. This includes checking for loose connections, corrosion, and other signs of damage. Any problems should be addressed promptly to prevent them from escalating into more serious issues. A qualified electrician should perform these inspections and maintenance tasks. Lastly, proper documentation of all electrical installations is crucial for future reference and troubleshooting. This includes keeping records of the wiring diagrams, equipment specifications, and inspection reports. Accurate documentation can save time and effort when it comes to maintaining and repairing the electrical system. In addition to the practical considerations, it's important to consider the potential liability associated with electrical installations. If an electrical installation is not performed correctly, it could result in property damage, injury, or even death. As such, it is essential to ensure that all electrical work is performed by qualified professionals who are familiar with the applicable codes and standards. Maintaining proper insurance coverage is also important for protecting yourself against potential liability claims. If you are unsure about any aspect of an electrical installation, it is always best to seek the advice of a qualified electrical professional. They can provide you with expert guidance and help you to ensure that your electrical installations are safe and compliant. Electrical safety is a shared responsibility, and everyone has a role to play in preventing electrical accidents and injuries. By following safe work practices, adhering to the applicable codes and standards, and seeking the advice of qualified professionals when needed, you can help to create a safer environment for yourself and others. Also, consider the environmental conditions in which the transformer is installed. In harsh environments, such as those with high humidity, extreme temperatures, or corrosive atmospheres, it may be necessary to take additional precautions to protect the transformer and its connections. For example, you may need to use corrosion-resistant materials or provide additional ventilation. The NEC provides guidance on selecting appropriate wiring methods and equipment for various environmental conditions. Additionally, be aware of any specific requirements imposed by your insurance carrier. Some insurance companies may have specific requirements for electrical installations, particularly those involving transformers. It is important to check with your insurance carrier to ensure that your installation complies with their requirements. Failure to do so could jeopardize your insurance coverage in the event of an electrical accident or fire. In conclusion, connecting conduit to dry-type transformers is a complex task that requires careful consideration of several factors. While the NEC does not explicitly prohibit the use of rigid conduit, it is generally recommended to use flexible conduit or cable tray in most applications. Always consult the NEC and other relevant codes and standards to ensure that your electrical installations are safe and compliant. And do not hesitate to seek the advice of a qualified electrical professional if you have any questions or concerns. Electrical safety is a shared responsibility, and everyone has a role to play in preventing electrical accidents and injuries. Remember to select wiring methods and equipment appropriate for the environmental conditions, and comply with any specific requirements imposed by your insurance carrier. By taking these precautions, you can help to ensure the safe and reliable operation of your electrical system.